All right, welcome everybody. So today we're going to talk a little bit about troubleshooting database performance and issues at scale. But before we do this, kind of picture this. Tell me if this sounds familiar. I'll ask for some hands. You know, sometimes when you're managing a large fleet of databases, it can be very hard to identify, where the issue is or if it's even the database. Do teams ever reach out to you saying like, hey, our retail service is slow, we think it might be due to this, or our ordering service is slow. We've looked at the front end, we think it's the database, you need to look at it, or we're not sure what the issue is. Does anyone ever run into things like that? I mean, I know I have for like the past 20-something years, right? And so today, me, Joe Aliotto, I am a senior solutions architect that focuses on cloud operations, things like observability and monitoring, governance, compliance, centralized operations management from like compute to database. I deal with a lot of stuff. So what we're going to talk about today is we're going to go into some customer challenges, like some common things we see kind of related to what I talked about today. We'll look at some fleet-wide observability, look at how we can do some end-to-end transaction analysis with application performance monitoring baked in, and then just a common troubleshooting workflow. Additionally, this will be online on YouTube in the next 48 hours as well. So this is recorded, so you will be able to view this again. All right, but before we do, let me introduce you to Alex. Alex is an SRE lead at Octank, and he's experienced with supporting, let's say like everything. He just supports operations, what it needs, right? He's the superhero that actually fixes things that's a little unsung in the organization, right? Alex is gonna be our champion today. So what Alex commonly runs into is like managing a wide variety of databases. Alex works with customers that have, or like his customers in the office, have different databases from like Postgres to MySQL to MS SQL, like Microsoft SQL and around. They have multiple different databases from different teams, and he has to manage that, as well as having a lack of application context has been a problem previously, right? So they say, hey, we think there's something wrong with the retail application. Like we looked at the application, it's fine. There's nothing wrong. I know it has to be the database. Being able to solve that and not spend the hours of back and forth trying to figure out what's going on has been a problem forever. And we're going to see how we can simplify that, right? Also having an ever-growing set of tools, like we have different tools for Postgres, for MySQL, for Microsoft SQL. We use different things to look at the databases there or the applications, right? And then also understanding how all of those work. They all have very specific characteristics that are for the specific database engines that makes it complex. So first off, here's Alex. Help me, Alex. Sales team's reaching out. Our retail service is slow. What's happening? Like, I don't know, but let me take a look, right? Alex is going to dive in. So what Alex is able to do is he's able to use the fleet-wide monitoring that gives unified access across accounts and regions. Kind of key thing is it's across 3 regions at a time currently due to some limitations, but he's able to see the different alarms, the different average load for the databases, the max load for those databases. You can see them in those honeycombs, and if it's high, it's red. If it's really low, it's white, kind of going down that scale. He can save those fleets to different views, like that retail prod application view. He can see those top 10 instances and be like, oh, this one has a lot of load. Maybe I need to focus my attention there. Additionally, he can look at the different events, seeing restarts, failures, different levels of severity that we've kind of opinionated built into there to understand what's going on, as well as application integration, where that prod retail service had 45% failures, right? Maybe that's an issue. Additionally, there's some top 10 metrics you can define by like CPU, memory, disk, network I/O, things that are important to you, and a table view at the bottom where you can kind of see that honeycomb in a table format. This is a great way to start to look at your fleet across your entire global fleet, identify where the problem's happening, and then dive deeper, right, into the instance view once you found it. So once you've found that instance, you can start to look at it and get the time span data at the top, right, where you can see each individual second during the time span, and then at the bottom you have the holistic time span, right? So you can see over the duration we're looking at right now, 1 hour, that we can see most of the queries were actually due, or most of the load was due to a specific query, right? You can view this in different ways, whether you want a line or a bar graph. You can kind of see the max CPU. Going above that max CPU is a general like load characteristic for the size of your database. If you're having sessions above that, that's generally a performance issue, right? And you can start to carve it out. But what's really interesting here is like, who's running the select star from orders? And it's consistently running, right? Who's doing that? We want to start to carve that out, right? So what we can do is we can go, okay, select that query, looking at that query, who's running this? It's the DBA intern. Why is he running? And why is it continuously running? Where's he doing that from, right? I can see he's doing it from these 2 hosts. So I know it's a DBA intern. I know he's running it from 2 locations. What application is he using, right? And so from there, I can see he's using the DB operations tools that they have from that application to kind of identify the who, what, when these things happen, right? And the where of when it's happened. We haven't answered the why, but this kind of gives you the information that now you can reach out to that team and say, hey, what's going on? You know, did they make a mistake? Is this something they need to clean up? Additionally, you can start to carve it out by the other like areas, right? You want to see which hosts have the most load, which users, which applications are generating the most load on this database. You could do it very easily, right? And so you kind of choose how you want to carve that up. Next, let's move on. Alex, help me. Sales team, we can't run our reports. We don't know what's going on. Can you help us fix it? All right, so he was able to find the instance where we already looked at the fleet view, but he found the reports. And what he's seeing is there's a lot of locking going on, right? And he's able to use Database Insights for this instance to start looking at the lock analysis or lock table that we have, or this lock tree, I mean, and we can start to investigate deeper. We can view the specific details that are important to us, but we could identify things like, you know, popular record locking scenarios, and all the other common ones. There's so many different locking scenarios you can run into. But we can start to get an idea of what's running, and then we can start to carve it out or slice out the views to get a better understanding of what's actually going on. Right now at the top, we're looking at the weights view, right? And we can see what are causing the different weights. We can see specifically what that is, where it is. We can start looking at the blocked objects. So if there was a specific single object that's blocking it, you would be able to see that and see it going across, see what the value of that is. And you can just kind of key in on the various aspects here. Blocking session, if you had a single session holding up, like a specific locking scenario that's holding that, you would be able to view that here, see it across the specific time span, and then be able to identify how you need to clear that up, which could potentially be an application issue, but we'll look at that later as well. So from here, what we can also do is we can kind of choose the segment we want to key in on. That lock tree is focused in that one area, right? So for this area, what we do is we can select that like minute time frame and then break it down by 15-second increments where we have this specific lock tree. So depending on the specific locking scenario, you're able to dive really deep to understand what's going on without having to leave the console. You don't have to connect to the database. It's just all kind of here for you. All right. So next, help me, Alex, right? Sales team again. Sales team needs a lot of help. Our order processing was having issues looking up orders. What happened? It happened sometime earlier today. We're not sure when. It was just having some problems. And so what you could do is you can go and look and see, okay, when we're taking a look at this specific query that they were using that we know is part of that, right? We could see during this time frame there were some issues. But you know, I can't tell much yet. I can see there's 2 execution plans that were run. Okay, so I know that something happened, but I only really see one right now. But if I change the pan to a plan view to slice it by that, I can see there's 2 plans. I can't even see the other one. Where even is that? Right? I can see there's about 8.5 average active sessions, and when I switch it to the other one, that's way more efficient. It went way down to like less than like 1/10 of an average active session. Right? It was being very performant. So now we can go down at the bottom, and it might be a little small, but you can see where we were doing like a full table scan right on that order tables. And actually, it's a separate 19th partition. And we can see we're doing the index only scan, right? For that yellow, the ones that were being efficient. And what you'll notice is that is on a different partition, right? Still on the orders table, but we can kind of see what the differences are. And we can also start to like look a little bit deeper into what the cause is for the SQL and start to understand when and why that happened. We know what's happening on a different table, but we can see what the specific executions plan were when they happened and dive a bit deeper from there. Next, help me, Alex, application devs, the good old app team. Our dev databases have been running slow recently. What's the problem? I don't know, but I'll find out, right? That's what Alex is gonna do, right? He has these automatic dashboards that are built in with metrics. He's done some of the other analysis already, but what he can do is he can go into his database telemetry. He has 18 different metrics that are already built into this dashboard per database engine. Per PostgreSQL, per MySQL, per whatever engine you're using. You update it once, it's gonna be across the entire fleet, having that same view. But we also have like hundreds of other metrics. Just search by keywords. Let's look for latency. I want some latency information, right? So I want to get my average reads and writes. I'm going to create a new widget that's specifically for that I can view across my entire database engine type, right? And so this is going to make it really easy to have those customized metric dashboards you want no matter what instance you look at. You do it once, and that's it, right? And so we can see that. We can see there's more reads there. Let's move on. Help me, Alex. This is the inventory manager this time, right? Sometimes it takes a long time to view our inventory, right? We're not sure what's going on, but we want to know more, right? So what you can do is, we also have some slow query analysis, right? When's it happening, why is it happening, and where, right? So we can go in and take a view in our database telemetry. If you've noticed, this is all in the same pane of glass so far. We've gone to different tabs, but we haven't changed to a different section. We're now looking at the slow queries. We can see query patterns. And then if we select a specific query pattern, we can see the patterns related to that. We can see how many times that's run. We can see like the average duration, what the 50% mark is, what the 95% of use cases are, and then the max, the ones that are running long. So this can help you identify a long running query that maybe you didn't know exactly was running long, and also find out when it was running long, so you can start to analyze what was going on. Next. So, help me, Alex. Application devs. Our retail service is having issues. It has to be the database. I know it's the database. I've looked at everything else. There's no way it's not the database, right? And so what we have is we've built in integration with application signals. We call it calling services. These are the services the database manages, right? So you have to have application signals configured on your applications, but we can see the fault rate of 47% on that retail service. But now we can see why. So what we're going to do is we're going to go into application signals. This is no longer database insights. It jumps us to application signals service, specifically that retail service we need to investigate, right? And from here, what you're going to see is it has a dashboard. It gives you an idea of like different service level operations, like availability or latency that are within thresholds you define. It can give you some operational audit information out of the box. Didn't do anything. It's just there. It can show you some high periods of latency. That's just there by default by kind of looking at it and understanding like, hey, this looks out of the normal, right? From there, you can take a look at the service operations. This is generally going to be like where the compute's happening. This is happening in Lambda for me. I built my application to run in Lambda. And I can start to see, what's happening here. I don't see any specific errors there yet. But let me look at the dependencies that run within that Lambda function. Okay, so I have this select operation, right? I have some other uninstrumented areas that need to be fixed. But I can see the fault rate's high on that select operation. So what's going on with that select operation? So what I can do is I can select the faults. I can start to view the spans. So spans give us an idea of what's occurring within that entire transaction. I see there's failures. I see how long they run. I can pop this up. I'm going to get a trace map in this trace details, end to end. Customer comes in, goes through API gateway. Something's happening with API gateway. Red's got to be bad. Right? I can see the Lambda function, the service that's running within the Lambda function, and when it's connecting to the database, right? Additionally, on the right, I can go down and view the actual timeline of the entire trace, right? I can view each individual span. I can see where I'm making that Postgres query. I can go directly back to the database from there if I want, and I can also view the specific query for that trace that's occurring during that specific span. And so this, if you're looking at this, you can see the duration it took to run that call. If that's within normal behavior of what you expect for that application, you know it's not related to your database. In this instance, I was able to find an error earlier up in the stack in the Lambda, and I can see specifically in the Lambda function on line 96 in the code of the Lambda function, that's where the stack trace error is being thrown. So I know it's within the threshold of what we wanted, but the actual application code threw the error and the stack trace and pointing to the exact line that it's at. Right? So as long as I know that that duration is within normal operating behavior, like expectations, then it kind of helps you point out what could potentially be wrong pretty easily. All right, thanks, Alex. Like I said, Alex is our superhero. He manages a lot of different things, but he was very easily be able to, from mostly a single pane of glass for his global fleet, be able to see how to fix those different problems, whether it was related to database load, execution plans that may have flipped or had bad plans. There's a lot of other things you can do for looking at the logs directly as well without having to change a single pane and search through those. And Alex saved the day. So with what we just went through and all the problems Alex solved, let's talk about a pretty generic troubleshooting workflow, right? So first, Identify the database instances and database load from the fleet view, right? Look at your fleet. If you don't know the exact instance you need to go to, take a look where it is potentially supposed to be, try to identify where there's high load. From there, dive a little bit deeper, look at the queries that are being run once you get to that instance view, understand where the load is, if it's related to locks or execution plans being changing, or what is potentially causing that, or if there is an initial more upstream load that's occurring and you have to address that, right? And then from there, also, review key metrics to help you kind of understand what's going on, right? So if you're looking at blocks per second per hit, understanding how many pages are occurring, how those are piling up, average active executions. There's so many metrics, hundreds of metrics. Okay, but things that can help you correlate, as you know, to understand what that load is and how it's changed over time. And then lastly, if you have application performance monitoring enabled for the applications in front of the database, you can very easily see how the end-to-end transaction's running. You can see where the latency is for the queries if that's within normal thresholds. And honestly, not just be able to track down when it is performing poorly, but you can actually set up some other alarms around it not behaving as you expected for those dependencies as well, which can make it a little easier to be notified before you actually have an issue happen and you're not sure what's going on. So with that, I have a few resources here. So these are just some real scenarios, right? Go ahead and take a screenshot of this. You can go to that QR code and you can review some very specific scenarios. There's also some database insights documentation. So on the documentation, there's a detailed section for execution plan analysis, lock analysis, and some other area functionality that's in there as well. And you gotta love the cat, super cat. This is more observability as a whole, not just database insights. But if you go to this one QR code, it has a bunch of best practices on that page. It's going to take you to a GitHub page where we have our observability best practices. It has a lot of really good links in there. And then the next thing, it's early in reInvent. The expo hasn't opened, but when it does, in AWS Village, we have CloudOps kiosks. We have everything from CloudOps management, observability, governance compliance, resilience, AIOps, multi-cloud, and more. Yeah, just come to the expo. No, I will be at the expo on Wednesday between 12 and 4 doing the AIOps booth, which I'm doing that, as well as the observability booth, where if you want to talk more about database insights or other observability for your applications, I will be there, happy to talk to you. And with that, thank you all so much for attending today. Please remember to do the session survey for COP331. That's how they rate me. Let me know if they want me to come back, or if you want me to come back, how we can make this better for you. And I hope you all have a wonderful time at reInvent. Ride the Datadog slide. It's amazing. It's fun. It's one of my favorite things to do. I do it every year. And check out the expo. Check out all the partners, the other sessions, everything that interests you. I'll be right over there if anyone wants to chat right after this. But with that, thank you all so much for being here. And hopefully I get a chance to talk to you all in just a minute. Thanks.